Hello viewers, Swagadaruna taking you through the story for A-Level Applied Mathematics. And this video we're going to go through the marking guide for Senior 5 Math Part 2 end of Term 1 for the year 2024. So this paper is suitable for seniors in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are some of the papers we hope to upload, and today we are going to go through the marking guide for Senior 5 2A Statistics done at Mengo Secondary School. So I saw someone in the comment section from Uganda Matters Namugongo. So I encourage you to send me papers you did on my WhatsApp line, which is this, so that I can also add you on the list. Then also for King's College Woodrow, the one who sent me pictures, they are a little faint, so I couldn't figure out some values. So if there's anyone here from King's College Woodrow, you can send me those tests you did so that I can also upload them. Then there is someone who asked me for soft copies of these papers. I also don't have soft copies. What I do, students send me pictures of those papers, then I just type them, and when I finish typing them, that's when I upload. So it's not that I have them in my archive. So there are some books you'll need at A-Level. There is Math for Principal Mathematics. There are 4 books: Math Part 1, Math Part 2, Topical Question Bank, and Termly Papers with marking guides. For subsidiary math, there is only 1 book with notes, Termly Papers with marking guides, and also NEB Papers with marking guides. For physics, there are also 4 books: Physics Part 1, Physics Part 2, Topical Question Bank, and its solutions. So now we shall go through this guide. So this guide is mainly on statistics. Section A, question 1 says, numbers, these ones up here, have a mean of 5 and standard deviation of √8. Find the median of the numbers. So shall come and say that summation, because they told us the mean and standard deviation, so we need to get summation of x, where we add all the numbers, come up with this. Also summation of x squared, because they talked about standard deviation, which gives you that. From there you can code the formula for mean. Substitute mean summation x capital N. We are using capital N because small n is already in the question. So cross multiply and get equation 1. The next was standard deviation. Given by that formula, substitute standard deviation summation x squared capital N and mean squared. Then you can square both sides, come up with that. Simplify by taking this side, then cross multiply and get equation 2. So remember, we already have equation 1, so I'm going to substitute equation 1 into equation 2. So where there is m, I put there this. Expand and collect like terms to get a quadratic, which can be solved using quadratic formula. Then you get the value of n. From equation 1, I can get the value of m. So substitute for n and get the value of m. Then they wanted the median, meaning I have to list them, and I cancel this with this, this with this, and this with this. So we have 2 middle values. We have to get the average, and that will be the median they wanted. Then question 2 says the weight of 40 students were as follows. Using a known value of x, determine the model weight of the students. So the good thing, they've given us the total frequency. So when I add all this, I must get 40. And that's why I begin from. Total frequency is that, substitute frequency is that, and all of this is this. Make X the subject, and that is it. So those are the marks for value of X. So now that we know the value of X, we can now go and get our mod. So first of all, you should realize that these are unequal class widths, so you need a column of frequency density. Otherwise, if they are equal, we would just look through here and see the model class. But now you can get model class, so you have to first draw a column of frequency density. So we shall come here and tabulate our values. We shall begin with what is given, the weight. Then we shall go to frequency. So here you can't add any upper class boundary because the widths are unequal. Then frequency is that. So the value of X has been replaced with a known value. Then class width, this minus this, this minus this. Even here it is 50 minus 10. So 80 minus 60, 90 minus 80, 100 minus 90, and this one you can't get it, so you leave it blank. Then shall go to frequency density. So this over this, 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 and this over nothing to 0. So now I know the class, the model class, which is 1, class with the highest frequency density. So after knowing that, this is the model frequency. So delta 1 or D1 is this frequency minus the pre-model frequency. Sorry, we are here. Frequency density minus the pre-model frequency density, which is that. Then delta 2, model frequency minus the post-model frequency density minus the post-model frequency density. Then you can code the formula and substitute lower class boundary, which is this here. Then D1, which is calculated here. D2 calculated here. D1 is here. Class width is here. Then you can use a calculator to get the model weight, and that's what they wanted. Then question 3 says, what should be the least mark if Mr. Mutumba Joshua should get in his 7th exam to attain a first class if he has an average of 78% in 6 papers, and that a first class can be obtained with an average of at least 80. So they told us that the mean should be now at least 80. That means it is that or more. So we shall come and write an inequality of mean being greater than or equal to 80. Then we shall substitute. This is the sum of all the 7 now, divided by the 7, greater than or equal to 80. So cross multiply and simplify to get the value of m. Then we can conclude that the least mark should now be 92. It should be 92%. And that's what they wanted. Then question 4 says, the table below shows the marks of some students in a promotional exam. Draw a histogram and use it to estimate the model mark. So the first thing to do is to realize that these are equal class widths. And that means that we should just we need to get frequency. So you come here and write what is given first, the marks, then the cumulative frequency, then the frequency, write this one here, then this minus that, this minus this, this minus this, this minus this, this minus this. We also need class boundaries. So class boundary for this, for this, for this, for this, for this, and for this. Okay, so now we shall get our graph paper and do the graph work. First is to label the axis, draw the axis. I think realize the space I'm leaving. I'm not drawing my axis in this middle here, because I'll ask what is all this space for. So you should leave only what you can write on. So I'll come and use intervals of 2 centimeters and get a scale for it. Label the axis, do the same for the vertical, intervals of 2 centimeters, and get a scale for it. So in O level, you could put your frequency and your class boundaries, but now we encourage you to you should put what is given in the question. In the question here it is marks and here it is number of students. So that's what you put. Then you can now draw from this to this, we have frequency of 5. From this to this, we have frequency of 8. From this to this, we have frequency of 10. From this to this, we have frequency of 15. From this to this, we have frequency of 22. Then from this to this, we have frequency of 24. Okay. So now we can get our mod by, so here there's nothing after this, so it has to join from here to here, then also from here to here, and you drop a perpendicular at that point of intersection. Then you read off that value, and that will be the answer. So how did we get it? We know that from here to here, one small square represents 0.9. Because from here, how did you get 0.9? You look at this. 9.5 minus 0.5 is 9. Divided by 10, it is 0.9. So it means that from 45.5, you add on one small square. Now I want you to realize something. If you have drawn this graph, you realize that this line is not exactly on the one small square, but it is very close to it. So you shouldn't forge to squeeze it to make it fit on the one small square. No, draw it where it is. Then when you are reading, because it is very, very close to it, you take it as one small square, which is 0.9. So when you add the 2, you come up with 46.4. And that's what they wanted. Then question 5, the sum of 20 numbers is this, and the sum of their squares is this. Determine the standard deviation of the numbers. So we shall come and substitute. We know that n 20 numbers, so n is 20, summation of x is this, and summation of x squared is this. Quote the formula for standard deviation and substitute into the formula, then use the calculator to get the output. And basically that's what they wanted. So M1 was for seeing this inside the square root, then putting the square root and output. Question 6 says the table below shows marks of some students in a math test. Use the table to find the median mark and the mean mark. So median shall need a column of cumulative frequency. So here ideally they should be in ascending order, but I think we realized something here. The order was not ascending. So what you do, you leave it as it is. So we shall get the values of x, then the values of frequency. We shall need cumulative frequency. So we need fx because of the mean. So multiply this with this, this with this, this with this and that, this and this, this and this. Then add up all these ones. Then we need cumulative frequency. This here plus, so this plus 9, 13 plus 12, 25 plus 7, 32 plus 5, 37 plus 3, like that. So Roman 1, they wanted median. You first get the median position, which is 20. So you look for where 20 lies. 20 lies here. So the corresponding value for median is 35. So in ungroup data, you only state, you don't calculate. You don't only state the median, quartiles, percentile, like that. Then Roman 2, they wanted mean. So summation of fx over summation of f to give you 30. And that's what they wanted. So now we shall go to question 7. Question 7 says, 6 numbers have a median of 7. Okay. The biggest and second biggest numbers are twice the second smallest and smallest numbers. So that means that the biggest is twice second smallest, and second biggest is twice the smallest, respectively. Determine the numbers if their sum, okay, is less than half the square, half the square of the biggest number by the sum of the middle four numbers, and that the range of the numbers is equal to the second biggest number. So here what we do, we don't know the 6 numbers, so we shall put unknowns, but to be safe, the numbers should be in ascending order. So the smallest followed by this, followed by this, followed by this, like that. Then we shall go to what is given. They told us the median is 7, meaning if you cancel this with this, this with this, you remain with 2 middle numbers. So c plus d over 2 is 7. When I cross multiply, I get equation 1. Okay. So then they told us the biggest, which is f, is twice the second biggest. That's why I'm putting here f is equal to b. Then they told us the second biggest, which is e, is twice the smallest. That's why I'm putting here 2a. So I'm going to rewrite the numbers replacing e and f with 2a and 2b. Then also they talked about the range. They said the range is equal to the second biggest number. So range is biggest minus smallest. So 2b minus a is equal to second biggest. Collect like terms to get 2b equal to 3a. Make b the subject, you'll get b equal to 1.5a. So I'm going to replace where there is b, I'll put there 1.5a to come up with that. Okay, then they told us something here. The sum is less than half the square of the biggest number by the sum of the middle four numbers, meaning that the sum of all the numbers is equal to half the square of the biggest number minus the sum of the middle four numbers. That's why what the word less means. So you'll come here and say that sum is equal to, first of all, this, which is that. Then the sum of the middle four numbers is this, which is that. That means that the sum is equal to half the square of the biggest number minus the sum of the middle four numbers. So I'll come and substitute this sum here and this sum here. Then the square of the biggest number was 3a squared. Then half of it. That's what they mean. Now we have achieved to get only one unknown in this equation. So we have to simplify and solve that and make a the subject or get the value of a. So open brackets, collect like terms, you'll get a quadratic which can be solved using quadratic formula. So let's marks for this slide. So when you use a quadratic formula, you'll get two values of a. A is equal to 4 and a is equal to negative. But a cannot be negative. Do you know why? Let's see why. Because they are in ascending order, meaning that these ones, okay, let's use this one. If I put a negative value here, it means that now all these values are going to be negative, which is not possible because they are in ascending order and these two middle values add up to 14. So we can conclude that a is 4. When a is 4, I can get now the numbers in ascending order. Remember, that's what was given, so substitute for a. Where there is a, you put it there. Then you simplify to come up with this. Now these are only two unknowns. Remember, the sum of these ones should be 14. And because this is 6 and this is 8, the only pair to give 14 is 7 plus 7. So we are going to put there 7, 7. And that is what they wanted. Then question 8 says find the Spearman's rank correlation coefficient for the following data and interpret your values. So you come and tabulate. So begin with values of x and list what is given. Then go to values of y and list what is given. Then you shall begin to rank. Ranking is done in descending order from biggest to smallest. So I'll find out which is the biggest. Is this, so to get rank 1. Followed by this, so it gets rank 2. Followed by this, so it gets rank 3. Followed by this, so it gets rank 4. Followed by this, so it gets rank 5. Followed by, now these are two values which are similar. Now for identical values, they must get the same rank, and that rank should be the average of the would-be position. Would-be means if they are different, one would be 6, another one would be 7. So the average of the would-be position will be now 6 plus 7 over 2 to give you 6.5. And that's what we put on both. So here we shall come and put 6.5 and also here 6.5. Then next is 38. Remember, we have taken the position 6 and 7. So next will be position 8. And lastly, position 9 or rank 9. We shall also do the same for values of y. Biggest is this, so it gets rank 1. Followed by this, so it gets rank 2. Followed by this, so these are 2. The would-be position would be now 3 and 4. So come and get the average of those. 3.5, so this gets 3.5 and also this 3.5. From 4 we shall go to 5. So this takes rank 5. This takes rank 6. Now there are still 3 more. We have reached rank 6, so one would be, the would-be position is 7, 8, and 9. So average of those 3 will be 8. So this will take rank 8, this also rank 8, and this also rank 8. Okay, so we are done to rank. Now we shall go to D, which is the difference. It is you to choose the order. You can say this minus this or this minus that. Whatever is okay. So difference here, 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 and here. Then we shall square them to eliminate the negatives. This squared, 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 squared. Then shall need the total of all these values, which will be this. After that, we shall remember to code the formula. The formula is there in your logbook. For example, logbook on formula number 115 is about Spearman's rank correlation coefficient. So I can come and quote it, substitute, and get the output. Then they told us to comment. First of all, the value is 0.8958 and the pairs are 9. So I'll come here, I'll look for pairs. They are 9 here. So 9 corresponds to this and to this. So the value you have got is bigger than this and also bigger than this. And here they said significant if the value you have got exceeds this stable value. So because it exceeds at 5% and it also exceeds at 1%, we can come and comment now and say either we shall say significant at 5% or one can choose to say significant at 1%. So any of the two comments is okay. And that's what they wanted. That was section A. Now we shall go to section B. Question 9 says, the table below shows the weights of maize in tons carried by different cars to a certain mark. And these are the weights. Then here they said, construct a frequency distribution table with classes of equal intervals of 500 kilograms. Now 500 kilograms is, first of all, 1 ton is equal to 1,000 kilograms. Therefore 500 kilograms is equivalent to a half a ton. Starting with a class whose lower limit is 0.5. Then using an assumed mean of 2.8 tons, determine the variance of the weights. Okay, Roman 3. Draw an ogive and use it to determine the limits of the middle 4 deciles of the weight, or the weights. So one, we shall need to tabulate because they have to draw a frequency distribution table. So we shall come here and draw the table. So the weights we have put, now weights we need to tally. We shall first put using the intervals given. Now they said intervals of 5, but for us, if you subtract, you get 4. Do you see something? Why? Because these are not class boundaries, these are class limits. If these were class boundaries, you'll get the interval by just subtracting. So shall come, there are different ways of, in O level, they will tell you that you should tally. So here, even if you don't tally, what you want is the column of frequency which is correct. So that's what I'm going to also do. I'll bypass the tally and come here and say, and get the number for each. So let me first start with values from 0.5 to 0.9. I'll count them. 1, 2, 3, 4, 5. So that is 5. Then also values from 1.0 to 1.4. 1, 2, 3, 4, 5, 6, 7. So there are 7. Therefore, I shall come here and say, first of all, these were 5. These are now 7. Okay. Sorry. 5. Let me first write it there. 5, 7. Then I can remove these ones. 1.5 to 1.9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll come and write here 10. Then 2.0 to 2.4. Also count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'll come and write 12 here. Then from 2.5 to 2.9, I'll still count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'll come and write 16. Okay. Then 3.0 to 3.4. 1, 2, 3, 4, 5, 6, 7, 8. So I'll come and write 8. Then 3.5 to 3.9, there are 3. Okay. And 4.0 to 4.4, there are also 3. So those are the frequencies I'm going to write. 5, 7, 10, 12, 16, 8, 3, 3. So let me do that. So I'll come here in the column of frequency and write them there. And I'll need to add the total of all this to give me total frequency of 64. Then values of x, which are the midpoints for this plus this over 2, this plus this over 2, add over 2, add and divide by 2, add divide by 2, add divide by 2, add divide by 2, add divide by 2. Then I'll need the column of d, which is the deviation. Remember, they were given assumed mean as 2.8. So d will be got by saying this minus 2.8, 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 minus 2.8. Then I can get fd. Multiply this with this, 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 and this with this. Then add all these values. When I add, I'll come up with negative 31.4. Then also fd squared. So fd squared can be got with from these two. This with this, this with this, this with this, this with this, this and this, this and this, this and this, and this and that. Still add all these values, you come up with 66.14. Then cumulative frequency. So 5 plus 7, 12, 12 plus 10, 22, 22 plus 12, 34, 34 plus 16, 50, 50 plus 8, 58, 58 plus 3, 61, 61 plus 4 plus 3, 64. Then you shall need class boundaries. For this, it is that, this, 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 and that. So it is from this class boundary that you can get an interval of 5. For example, this minus that, it is 0.5. This minus this, 0.5, 0.5, like that. So class intervals got from class boundaries. So here there was a mark for column of frequency, which is correct, values of FD, values of FD squared, and values of CF. Then we shall now go to the question. Question said, using a assumed mean of this, find the variance. So we shall come here and get the variance. It's given by that formula. Substitute and get the output. And that's what they wanted. Then Roman 3 says, draw an ogive and use it to determine the limits of the middle 4 deciles of the weight. So ogive, we shall need a graph paper. So we shall come here and put a graph paper. Then draw the axes, horizontal and vertical. Use intervals of 2 to 2 centimeters to get a uniform scale for the horizontal. Same applies to the label it, then same applies to the vertical, 2 to 2 centimeters, and get a uniform scale. Okay, then now we can plot. We are plotting these values. This here and this. So 0.95 corresponds with 5, this with 12, 22, 34, 50, 58, 61, and 64. So you come and plot them. So here it corresponds with that 5, this with 12, this one with that, this with that, corresponds with that, 50, corresponds with that, corresponds with that, and lastly this one. Then shall draw a reasonably smooth curve through all the points. And don't leave it hanging, so it must touch the origin, the starting point. So that will be that. So that is the ogive. Now let's see the questions they want us to get. So from there they say draw an ogive and use it to determine the limits of the middle 4 deciles of the weights. So you need to know which particular decile do they want. So I'll come here and first make a simple sketch to help me identify the deciles. First of all, deciles are divisions up to 10 divisions. So the midpoint will now be 5. This is 5. 4 deciles to be placed at the middle, it means that there will be 2, 2 on either side of this midpoint. So left hand side there will be 2 deciles, right hand side there will be 2 deciles. So what value will be here? It will be 5 minus 2 to give you 3, which is D3. Here it will be 5 plus 2 to give you 7, which is D7. So I'll come here. That means that the lower limit is D3 and upper limit is D7. So let me first get D3. So for D3, the position is 19.2. So I'll come here and read and read off 19.2 here. Take horizontal line to meet the curve, drop a perpendicular to meet the vertical axis, to meet the horizontal axis, and read off that value, 18.15. How have you got 18.15? One, you realize that each small square, okay, from here to here, it is 0.5, meaning that each small square is 0.05. Okay, then I'll come from 1.45. How many small squares do I count up to here? There will be 8 small squares. Therefore, I'll come here and say that lower limit will be equal to this 1.45 which you read. Then these are the 8 small squares and value for each small square to give you 1.85. Let's do the same for D7, which is the upper limit. Position is 44.8. So I'll come here and look for 44.8. Take a horizontal line to meet the curve. Drop a perpendicular to meet the horizontal axis and read off that value. So still I'm going to do the same. Here it is 2.45. Then how many small squares? They are 6. So I'll come here and say 2.45, 6 small squares, unit for each small square, you'll come up with 2.75. And basically that is what they wanted. So now we shall go to question 10. It says, below is a summary of the heights of 40 students in a certain school. Calculate Roman 1, standard deviation Roman 2, semi-interquartile range, and Roman 3, the required height for one to be included on the basketball team if 70% of the students were included on the team basing on their height from the tallest one. So questions of group data, you have to tabulate. So I'll come and tabulate. When you see inequalities, it means class is the same as class boundary. So I can combine them into one column. Then cumulative frequency. Now here there was something funny. Let's analyze this. Here they said 40 students. But if you add all these ones, you'll come up with a value which is very, very big. Okay. So for you to identify that this is a cumulative frequency, look at the last value and this one. If they are the same, it implies that the numbers given here are for cumulative frequency. And two, you also see them when they are just increasing, but with 40 as a maximum. So that was the major trick, and most students couldn't identify it, and therefore lost all the 12 marks. So here we shall come and put cumulative frequency. Then we can now generate our frequency. This minus that, this minus this, this minus this, this minus this, this minus this, and this minus that. Then total is of course 40. Then values of x, which is the mid-mark, average of this plus this over 2, this plus this over 2, plus this over 2, add this over 2, and add this over 2. Then you can get fx. Fx will multiply this by this, 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 this by that. Then add all these ones to get a total. Then fx squared, this by this, this by this, this by this, this by that, this by that, this by that, and this by that. Then add all these ones to get a total. Okay. So now we shall start. Let me see the questions. First one was for standard deviation. So standard deviation, quote the formula, substitute summation of x, summation f, summation f, summation fx. Then use the calculator. That was Roman 1. Then Roman 2 was semi-interquartile range. For semi-interquartile range, first is to get the position. So lower quartile position is that. Therefore, I'll come here and look for that position. 10, where does 10 lie? You realize that 10 lies here because in this column of CF, it doesn't lie here, it doesn't lie here, but it lies here. So that becomes your class. When this is my class, I'll need a number of things. One, frequency of that. Okay, I'll begin with the lower class limit. Lower class boundary of that class is 40. Frequency is 17. Cumulative frequency before is 8. And class width is 10 when you subtract these two. So those are the ones I will substitute here. So lower class boundary 40, position is 10, which is here. Cumulative frequency before is 8, frequency of that class is 17, and class width is 10. So as a calculator, you come up with the lower quartile. Then do the same for upper quartile. The position is 30. So I'll come here and look for the position of 30. 30 is here. So still do the same for that class. Lower class boundary is 50. Cumulative frequency before is 25. Frequency of that class is 5. And the class width is 5. So I'll come here lower class boundary, that position, cumulative frequency before, frequency of that class, and class width to give you 55. After getting upper and lower, I can now get the semi-interquartile range. Subtract, divide by 2 to get the answer. That was Roman 2. Then Roman 3, let's see Roman 3. Roman 3 said that calculate the required height for one to be included on the basketball team if 70% of the students were included on the team basing on their heights from the tallest one. So from the tallest means from here they counted 70%, meaning that the ones this side are 30%. So that position for 30% is called 30th percentile. So I'll come here and say the position is 12. So I'll come and look for 12 in the cumulative frequency column. Twelve still lies here, so still we shall use the same as it was for lower quartile, whereby the lower class boundary is 40, cumulative frequency before is 8, frequency is 17, and class width is 10. So minimum height is P30, so substitute lower class boundary, position, cumulative frequency before, frequency of that class, and class width. You will come up with that as the minimum height. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on end of term 1 math 1 for the year 2024, still for the same school, Mengo SS. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit as a family.